Hello CS400, this is Parker, and today I'm going to be talking about a specific type of hashing algorithm, uh, actually a cryptographic hash function that's called SHA-1 or Secure Hash Algorithm 1. Previously, we've talked about hash codes, especially for like Java in relation to implementing a hash map or a hash tree efficiently, which is kind of a maps a key to a value. And to do this, most implementations use a hash code generating a unique integer um, that so they can quickly find that pair based off the key. Um, so generally you try to generate some kind of unique number based off of your object. For example, say if I have a book object, and I have a name and author, I could write an algorithm such as this that tries to generate unique hash code based off of the name and author. This basic implementation just uses the hash code of the name and the author, as well as some simple math, and timesing by 32 to get some random results. This will provide us, as long as like the author and name are different, of course, will provide us with some unique results that is unlikely to have any clashes, or especially since like we're returning an int, which gives us quite a bit, because an int, if you remember, is 2 to the 32, so that's like quite a lot of space. But beyond just implementing hash maps, there's other use cases for hash functions, such as security and cryptography and things like that. So many people have created algorithms that are maybe more secure, have less collisions, and can support many more unique things without having the same result, such as the United States NSA, National Security Agency, has created or at least put money towards creating some standards in the past. One of the earlier ones was SHA-1 from the early mid-90s, and it was used for many things. People have used it as parts of generating secure password representations, for implementing algorithms such as TLS and SSL, which are often what you use for like connecting to your browser, and many other things like that. Nowadays, though, this has changed, but I'll explain that a bit later. So we talked about this hash code, which returns an int 2 to the 32. Well, SHA-1's quite a bit different. What it does is it takes any input, which is kind of nice about a hash function, and it will produce a 160-bit hash value no matter what. This is known as a message digest, and different hash functions can result in different lengths of hash values, or different lengths of message digests, but SHA-1 does result in 160 bits, and we often represent this in a 40-digit hexadecimal number, because of course 160 bits can be represented with 40 hexadecimal numbers, because every 4 bits can be represented with one hexadecimal number, but that's just another representation. And it has many use cases in the past, and especially since 160 bits is quite a lot, and for a long time there was no collisions. There was no way to like trick the algorithm to say like, oh, this thing is not what it is. So like one use case we use for hashing algorithms is to say we generate a hash based off this file or this message, and this is the resulting hash, the hash value, and this is unique. And you cannot go backwards, so you cannot take that hash value and figure out what the original thing was, but what you can do is you can take the original thing and you should get the same hash value every time. Now this is what we expect from it, but now SHA-1, as well as other past algorithms, have been shown to be not foolproof. For example, in 2017, Google and another company proved that they were able to take 2 different PDFs and generate the same SHA-1 hash. So this shows that there was a collision attack, and theoretically someone could try to pretend to be something it's not. And as well, the idea of being able to not reverse a hash value is not so perfect because SHA-1's a really quick algorithm to run. So what you can do is you can brute force basically every possible input and see which input matches your output. This is why we don't use cryptographic hash functions alone to generate passwords. And you should never actually write your own password hashing algorithm because they're actually really complicated and they involve many steps, including hashing as part of that step, but lots of hashing, different steps of salting and peppering, which I won't go into, but it's part of it. So it's important that we have these algorithms, but we also have to be careful that we're using one that is still proven to be secure and there isn't any collisions. For implementing Java's hash code, maybe it's not so important because, okay, the small chance is we don't have an insane amount of books. 2 to the 32 can represent quite a lot of books, and you know, it's not a very large chance that there's going to be a collision in there, and even if there is a collision in our books, it's not a super big deal. But if you're working with secure information, passwords, it's a pretty big deal. So while SHA-1 may not be the best anymore, for many use cases it is still good. For example, Git commits are often tied to a SHA-1 hash to identify a commit. And there are many other use cases as well because it is a quick hash function, and quick can be good. It's so yeah. I'll show you the example of how to implement one in Java. It's pretty easy. Generally you shouldn't try to implement your own. Most languages or most libraries should provide you with an already existing one. So luckily Java has a built-in implementation of SHA-1 that we can trust, that we know it works. So there's some ideas to it. The basic idea is we're going to get a message digest object, and we're going to create a variable. The idea, if you remember, the message digest is the final hash value. So what we can do, we can call it like message digest. It doesn't really matter. And we're going to use a static method from this java.security library inside of the message digest class, actually. So what we can do is we can get the instance, and there's different methods, but we're going to worry about this main one. It allows us to specify what algorithm we're looking for. There's other ones that Java provides. Different Java implementations might provide extra ones, but the primary one we're going to care about is SHA-1 in this case. And you're going to see it is going to give us a red error because there's a possible of this algorithm not existing because we're just specifying a string. So it's java.security.noSuchAlgorithm exception. You can either just go ahead and add the exception to the method signature, or you can try and catch it. Since I know SHA-1 exists and I'm not so, if it happens I just want the program to exit, I'm just going to add the exception to my main method signature here. Now, what you can do with this message digest is we're going to build a byte array, because actually we talked about it. We're just going to make that 160-bit hash value. You can call this whatever you want. I'm going to call this like digest or something, and we can access our message digest here, that we got, the instance of the SHA-1 algorithm, and from here we can, there's different methods. The main one we're really going to care about here is .digest, and it accepts a byte input. So in here it's going to take bytes of any length. That's the nice part of an algorithm in an array. But generally we have a string, and strings have some nice utilities for this. So say, for example, I want to say like CS400 is a great class, and I maybe want to get the hash value for this function so people can check like, oh, and I can send them the hash function, they can maybe check like, oh, and I can send the message and the hash, and it's like, oh, is this the original message? I can compare, I can run SHA-1 on it and check like, oh yeah, this is the original message because I got the same hash value when I ran SHA-1 on it myself. So now the problem with this is that it doesn't accept a string, it accepts a byte array. So what I can do is I can do get bytes, which as you can see returns a byte array, which is what our message.digest method accepts. And from this it will give us our byte array, our final digest. This is an array of bytes, maybe not so useful, and generally, as I said before, we like to look at it as a hexadecimal number because it's easy to read, 40 long. So what we can do is Java has some other utilities such as a big integer, which is basically a high percent integer that can represent a pretty big number. I'm just going to call it converted, and what you can do we can just go ahead and pass in our digest that we made. If you want to see this method, you can always look at the Java docs, but since we're here, we can go to this, and I'll show you that what's this doing is it's translating the sign magnitude representation of a big integer into a big integer. The sign is represented as an integer signum value, -1 for negative, 0 for 0, or 1 for positive. The magnitude is a byte array in big endian byte order. But basically the idea is what's the sign of our number, and then what's the number we're trying to make a big integer out of. That's kind of that idea. So then I'm just going to go ahead and open my file back again. Okay, so now we have our big integer. What we can do is we can convert this back into a string, because obviously we want the string representation so we can see what this looks like. You can call it whatever. I'm just going to call it string rep. And luckily, big integers have a nice method called toString, and allows us to specify a radix, or basically a base. And in this case, we want to specify a base 16. That's hexadecimal. That's what we generally look at hash values as. It's easy to understand. And hexadecimal is that like 0 through f idea, where f is 15. Because we have a base of 16, just like how in binary we have zeros and ones. And then what we can do is we can just go ahead and print out our string representation. So now we should get our string, our hexadecimal string representation, which is reasonable. This might not be 32 long, since it actually doesn't include like the pre-appended zeros, but yeah. So this hexadecimal representation, and you can see when we change our message, such as like UW Madison is fun, we're gonna get a different number. But let's keep in mind let's keep in mind this original number, this hex shit. So when I run it again, I should get the same thing. We'll come back to that, but say I say like, oh, Parker, which is me, is great, I should get a different representation. Yeah, and this is different. But as soon as I go back to CS400 is a great class, I should be getting this same digest. And as you see here, I get this same thing. So this is the use of these functions. We can reliably go to the same number over and over again. And I talked about some of the use cases, such as identifying something is the original version. But we have to be careful, like I talked about, because there has been collisions shown to exist. So nowadays we can explore other algorithms, and NSA has released other ones such as SHA-2 and SHA-3, and they've also funded research into other hashing algorithms, and there are many other ones out there that are pretty cool. For example, there was a new one in the past few years called Blake 2. It's open source and it's been adopted by many projects. It's shown to be secure and fast with different versions of it. So something to look into, but for many cases, SHA-1 is still fine. But as I said, you should never roll your own password handling. You should use a library such as scrypt or bcrypt. I won't go into those here, but they will use hashing functions such as SHA-1, or maybe a newer, better one to generate secure passwords. Because while we theoretically we can't go directly from this hash value back into CS400 as a great class, we could just try a bunch of inputs until we eventually found one that matches this, because this isn't that long. They could keep trying this over and over again. So keep that in mind, and yeah, this is a basic method of how to implement or use SHA-1 in Java. So yeah, thanks for watching, and have a good day. If you have any questions, let me know.